Notes on product and power rule. So the first thing that I want you guys to do is make sure to be taking notes on your own paper. Okay? All right, so the product rule. The product rule basically is going to be, we're going to be using it when we're going to be multiplying. The first thing that we do is we multiply coefficients. The second thing that we do is we use the product rule by adding exponents of like bases to simplify. So the product rule is used when we have two monomials that have the same base, like a and a, and then they have exponents. The exponents in this case are m and n. And what we do is the product rule says that to simplify this problem, you keep the base, the whatever it is, which in this case is a, and then you add the exponents up. Okay, so a couple of examples of this would be if we say had x to the second power and we were multiplying it by x to the ninth power. The product rule says to simplify this is you keep the bases the same, which are x, and then to simplify it you add the exponents up. 2 plus 9 would give me x to the 11th power. So by the product rule, x to the second times x to the ninth is equal to x to the 11th power. Okay, and this rule works no matter what the base is. So in this case the bases are variables. If I made the bases, say, a number like 5 to the third power, and I said multiply this by another base which was the same as the first base, 5 to the fourth power, the product rule says add the exponents together. So you keep the base, which is a 5, you add the exponents together, so 5 to the third times 5 to the fourth would simplify into 5 to the 7th power. Okay? Now, whenever we're doing the product rule, that's always the second step. You use it by adding the exponents, okay? If there are coefficients, you actually multiply them together. So let's say I had 2y to the fourth power, and I was multiplying it by 5y to the sixth power. What I would do to simplify this problem is I take the coefficients, and remember, coefficients are just the numbers in front of the variables. So the coefficient for 2y to the fourth is 2. The coefficient for 5y to the sixth is 5. So you would actually multiply the coefficients together, 2 times 5, which would ultimately give me 10. And then I use the second step that I do is I use the product rule by adding the exponents. So of the like bases. My like base is y. I take the exponents 4 and 6. I add them up. So this problem would simplify into 10y to the 10th power. Okay? All right. Then the second rule is a rule called the power rule. The power rule is when we have a base, a, and we have a power, m, and that is in parentheses, and then it's to another power. Okay? Some people call this the power to a power rule. All right? And the reason why some people call this a power to a power rule is because you're always going to have one power in parentheses with a base, and it's going to be raised to another power. Now, the power rule says when this happens, you multiply the powers or the exponents together. Okay? And there's always two steps you have to remember. The first step is the outer exponent, which would be n, applies to all inside terms. And then the second step of the power rule is you use the power rule by multiplying each exponent of each term. Okay, couple examples of this. The first example would be if I don't have a coefficient and I only have one variable, like say x to the fourth power, and then I have that to a power of say 3. Okay, so here I have a power and then a 4, and then I have it to another power. Okay, so since there's only one term here, we're really going to skip step number 1, which says the outer exponent 3 applies to all inside terms. The only inside term is x to the fourth. And then step 2 says use the power rule by multiplying. the exponent. So what I would do here is I would keep the base as x, and then the power rule says you multiply the 4 and the 3 together, so this would simplify into x to the 12th power. So x to the 4th power in parentheses to the 3rd power simplifies to x to the 12th power. Okay, now if you do have a couple of different terms inside the parentheses, then that's where we'll do step number 1. So like this, let's say I have x to the 2nd power, y to the 4th power, and that's all in parentheses, and then I have an outer power of 5. Okay, so the first step, the outer power, the outer exponent, 5, it applies to all the inside terms. So that 5 applies to the x to the 2nd, so I'm going to have x to the 2nd and then to the 5th power. And then it also, that 5 also applies to the y to the 4th. So if I wanted to break this down and really think about what it means, x to the 2nd, y to the 4th to the 5th becomes that. Okay, then the second step says we use the power rule by multiplying exponents of each term. Okay, so to simplify the x part, I would multiply the 2 and the 5. That would give me x to the 10th power. To simplify the y, I would multiply the 4 and the 5. That would simplify to y to the 20th. Okay, so x to the 2nd, y to the 4th, to the 5th power simplifies into x to the 10th, y to the 20th power. Okay, applying some of these examples here. So in the first example, it says simplify the expression. So you could see there are no outer powers, so I do not have to use the power rule. The only thing that I'm doing is I am multiplying these two expressions together. So I'm going to use the product rule. The product rule says, first of all, you multiply the coefficients. Okay, so the coefficients in this case, the first parentheses coefficient is 8. The second parentheses coefficient is -3. I'm going to multiply those together. That gives me -24. Then the second part of the product rule is I add the exponents of the like bases. So now I'm going to work with the variables that have like bases. The first one is the x's. So I'm going to take the x's and I'm going to add the exponents together to simplify it. 4 plus 4, that would give me x to the 8th power. Then I also have variables of y's, so those have like bases. So the product rule says you add the exponents together. So I'm going to add the 2 and the 9 exponents for the y's together. So this entire problem would simplify to -24, x to the 8th, y to the 11th. Okay, the next example here, and the last example that we may go over, is that you see in this problem I have a parentheses, -2ab to the 2nd, but then I have an outer power, or an outer exponent, which is a 2. Then in the second parentheses, 3a to the 2nd b, I have an outer power. Okay, so I'm multiplying two things together, but I also have an outer power. Now when this happens, we're going to have to apply both rules. So we're going to, and when you have to apply both rules, you always apply the power rule first, then the product rule second. So the power rule says, all right, the first thing I do is the outer exponent applies to all inside terms. So in the first parentheses, that outer exponent of 2 applies to every term on the inside of the parentheses. So writing this out, I would have a -2. That 2 applies to the -2. It also applies to the a, and it also applies to the b to the 2nd. So writing out the first parentheses, that's what that first parentheses becomes. Okay? And then I would also do the same with the concept with the second parentheses. So that outer exponent of 2 applies to all inside terms. So I would have a 3 to the 2nd power. That 2 applies to the 3. That outer exponent of 2 applies to the a to the 2nd. And then that outer exponent of 2 also applies to the b. Okay, and then what I would do is I would simplify each one of these by using the power rule.